Hobart School of Welding Technology presents Training in Gas Tungsten Arc Welding. Topic number 19, Job Practice. Stringer bead, flat position, with filler metal, aluminum. The objective of this job practice is to become familiar with torch and filler rod manipulation and current control to produce welds on 125 thousandths inch thick aluminum. Material. For the remaining job practices, we will be working with 125 thousandths inch aluminum plate. The pure tungsten electrode is used with alternating current. The shielding gas remains welding grade argon. The filler metal will be ER4043 and should be 3/32 inch in diameter. The equipment will be the same as used in the stainless steel job practices. Power source, AC-DC combination. Collet and collet body, 1/8 inch. Nozzle, 3/8 inch inside diameter. Protective clothing, gloves, and helmet. Stainless steel wire brush, wire cutters, and pliers. Machine settings. Alternating current is used on aluminum. The amperage setting is 140 to 150 amps. However, the current is varied by turning on the weld current remote control and using a foot rheostat. The hot start is set to 4 to aid in starting the arc. The post purge is 10 to 15 seconds to cool the torch and prevent puddle oxidation. The high frequency is continuous, and the control setting is set to 70 to provide a smooth arc. The gas flow rate is again 20 cubic feet per hour, and the tungsten electrode stickout is 1 to 2 electrode diameters. For welding aluminum, the pure tungsten electrode must be prepared with a shiny, round, hemispherical end. To do this, grind the end so that it is flat. New tungstens already have a flat end and do not require grinding. To ball the end of the tungsten, place a copper plate on the work table. Copper is used since it does not contaminate the tungsten. The torch should be positioned at a 90-degree angle to the copper plate, with an arc length no greater than 1/8 inch. Press the foot rheostat all the way down for maximum current. Do not touch the tungsten to the copper. As soon as the ball is produced at the tip, release the foot pedal. Once the electrode is ready, the workpiece is prepared by thoroughly cleaning one piece of aluminum with a stainless steel wire brush to break up surface oxides. If the aluminum is not properly cleaned, heat control will be more difficult and black specks of contamination may appear in the weld metal. Place the aluminum on the work table in the flat position. For a right-handed welder, position the torch at the right end of the joint. The torch is moved from right to left. For a left-handed welder, the torch is positioned at the left end of the joint and moved to the right. Hold the torch with a 90-degree work angle and a 20-degree push travel angle. The filler rod should be angled up from the plate 20 degrees with no side angle. Lower your helmet and start the arc by pressing the foot pedal and press until the proper heat is achieved to form a puddle 2 to 3 electrode diameters wide. Use the dip technique to add filler metal to the puddle. The rod is dipped in and out of the leading edge of the puddle as the torch moves evenly along. The filler should be added in even steps to maintain an even ripple. Keep a 1 electrode diameter arc length. As you move along the joint, it may be necessary to reduce the current to compensate for the buildup of heat in the aluminum. This is done by releasing the foot pedal a small amount. At the end of the piece, slowly decrease the current as you apply filler metal to the solidifying puddle. When the crater has been filled, remove the filler rod and continue to decrease the current until the machine shuts off. Hold the torch in position to allow the post-purge to cool the torch and prevent the puddle from oxidizing. When depositing the weld bead, be careful not to push the filler metal too far into the puddle. Touching the rod against the tungsten or touching the tungsten to the puddle. This will cause tungsten contamination. If this happens, regrind and ball the tungsten. The finished weld face should be evenly rippled, slightly convex, and 2.5 to 3 electrode diameters wide. Good cleaning should be indicated by a white line at the bead edges. This is actually the breaking up of the oxide coating on aluminum. Inspect the bead and then continue practice.